Yeah, Ketna, can you hear me? Hello, Ketna, can you hear me? Ketna, am I audible? Hello, Ketna, can you hear me? Ketna, am I audible?
Yes.
Alright, yes, we can start the session. I think I have shared my screen. So wait up a minute. Hello, Ketna, can you hear me?
Yes, sir.
Oh, yeah, fine, fine, fine. Okay, look, I was speaking, but I thought you were not speaking. Okay, I think I have shared my screen. It might be visible to you. It must be visible, right? All right, Ketna, let's look at this. Ketna, look, as far as I could remember, in the last class, you left early, right? Could you remember that? When I see that you were not in the session that time, I think so, if you could remember. So in that time, I gave you one problem, Ketna. Like, one was the simple example I gave. This kind of thing was there in the example. Uh, you were given that time. You were given current I from this branch. You are given current I. Basically, some you can assume it to be I2. You can assume it to be I1. They tend to sine of omega t. Okay, and the current is going in this way. So current was like I is equals to I plus I2. This is the current of difference. So you had to get the average and RMS. Average and RMS of this current from time is equals to 0 to time is equals to 2 pi by was I think Kirtana, you were not in the session that moment. So can you just please let me know? You were there in the session that time or not? Yeah, Kirtana, please. Kirtana, Your network is lagging a lot. I can see that. No, look, you're not audible to me in any ways. Just asking you something. Kirtana, please let me know. Look, there is no point of continuing further. If your network is delay, something is there, please let me know so that we can do things accordingly, right? Yesterday also you left the session in between. I was not even aware of it. I was speaking randomly. This is what I felt that time. Kirtana, should we discuss this thing or we can take the session the next day? Just let me know, clarify it once, okay? Wait, it's not there. First of all, look, don't type something because I don't have access for this screen all the time. Okay, most of the time I'm on the blank page, okay? So if you're writing something, I just can't go back and check it again and again. So this is the first thing I'm saying. So look, let's go with this problem once. You are given I is equals to A plus, look, why it is I plus equals to? Because look, if you look at this problem carefully, this is given as I is equals to I1 plus I2, right? So I1 is given as A, I2 is given as B times the sine of omega t. So what's the first thing you are supposed to calculate? First thing is average and this RMS. And time is given from 0 to 2 pi by omega. You know that this very well, right? So how to get the this average thing? You know, I average nothing but current dt integration. Okay. So Ketna, just let me know which part you want to solve. You want to solve average or RMS? I will solve one. You have to get the other one. Okay. It's your choice. Like whichever the problem you wanted to solve, you can let me know. You know what? I can give the answer for this. What I can say. This this average can be solved within a minute. You won't even take a lot of time to do this. Look, I don't know whether you can reply or not. If you see carefully, my current is something like this. Yes, current is something like this. I1 plus I2, right? So when you are going to do integration of this, at the end of the day, I can do it for the separately. I can do it for the separately, right? So basically, you can simply say that when you are going to take the average, we already know what is the average of these kind of situation. If you could remember, this is I naught sine of omega t. If you solve this further, what you used to get some value, right? But this time, what is the time period given? This time is given as 2 pi by omega, right? If you fill this as per the time period 2 pi by t, so you will figure out that this is given as complete cycle. In complete cycle, what is the average? That comes out 0. So this thing is resulting you the average 0, but this will give you an answer as A itself. So the average of this case will result you out A value. Okay. If you understood this part, please let me know. Clarify it once. Krishna, please clarify if you understood this thing. Because wait a minute, I'm really not sure. Kirtna, should we continue the session or you want it to the next day? Because look, it's quite unresponsive session ongoing. You can write it that we should continue or not, just in 2 words, okay? I won't force it for now. If your network issue is ongoing, you can actually I'll just continuous. I'll reason. Makes sense. Reason can do the sessions. Yeah, great. Now it's fine. Or not.
I'm audible.
Yeah, you're audible. It's fine now. Okay, look one thing. If your network is fine, then we are going to continue. Okay,
It's fine.
that's fine, right? Fine then. So let's go back to this. Okay, great. So here we come back. Did you understood this problem, which I was explaining to you?
Mm,
Okay, so you know why we got the answer A? Okay, leave it. We were actually discussing about RMS values. So are you clear how to calculate RMS values or something?
Yes.
You're clear, right? Okay, good. Now, so I'm going to give you one more graph. Let's say I'll leave this example. Okay, now another example. Let's take it. Well, we are not yes. Another example. Let's take it. You are given. Just find out IRMS where t from time t is equal to 0 to t is equals to 2 pi by omega. Okay, till here you have to figure out the RMS value. Clear? So look, I'll give you the solution. Don't worry about this. For these some examples, I'll give the solution. But what kind of graph you are given where I is given as a times of sine omega t plus b times of cos omega t. Look, if I ask you, let's before calculating the RMS, can we calculate the average? So the answer is yes. Calculating average is easy. Why it is easy? Look. because average does not depend upon the, what I can say, average does not depend upon your real values, right? It depends upon square. So when you do square, the negative becomes positive. Okay, so that's why when we're taking the RMS, that is different. That becomes little bit harder as compared to the average. So let's talk about what is going to be the average. You know that this is asking about 0 to time is equals to t. This is complete one cycle. Okay, this is complete one cycle we are talking about. So in this case, if I just make a graph of first part, first this current, it will look like this. From here to here, what is the net value? Positive some value, negative some value. Net is 0. For this part, B cos omega t. This graph comes out like this. Positive, positive, no, negative. Look, this is half, right? It is like K, this is like 2K negative sense, this is K. So again, the result is 0. That's why the average of this is going to be 0, but the real value is not going to be 0. Okay, what the real value you are going to get is, idea is very simple as far as I know. This part should result something, this part should result something. But when you do the square of it, there will be resultant will also come out of it. So that is what we are going to discuss. So look at this. How to get RMS? RMS is nothing but under root of average, square of average. Square of average. This is what the answer is. So first task is to calculate square. Okay, what is the square? If you do the square, you are going to get a square sine square omega t plus b square cos square omega t plus 2ab times the sine omega t cos omega t. Clear, Kitna? I hope this is right. Then, is there anything which I can write here? No, I don't think so. So I'll be let it be like a square sine square omega t. Yeah, look at this one. So we have got till here, right? Omega t. There's no point of rewriting this thing. You should be just knowing this that this formula is this formula is nothing but a. But you know, kid, now we have to do integration later on, right? So you know how to convert these things, right? Whenever you get sine, when you have to do integration of sine square theta, I'll just go back here. There's a formula. What is it? Identity. Cos times of 2 theta is equals to cos square theta minus 2 sine square theta. So this can be written in the terms of cos square theta. Look, you have cos square theta, you have sine square theta. Both of them you are having, right? So if you put here, this will become 2 cos square theta minus 1. Also, it will be can be written as 1 minus 2 sine square theta. Okay. So these are the two things. So what you can simply say that cos square theta can be rewritten. What is the what we I can write 1 plus cos 2 theta by 2, and this can be written as this thing can be written as this will go that so 1 minus cos 2 theta by 2. This is what I'm supposed to get. Is it clear? Are you clear with this? Look, this is not a complete identity. We have one more identity. What is it? Sine 2 omega, like sine 2 theta is written in the form of 2 sine theta cos theta. So if you see here, I have 2, I have sine omega t, cos omega t. So this thing becomes 2 times sine 2 omega t. Okay. So finally, I can rewrite your I square as a times of, look, instead of sorry, it should be this is cos. Wait, let me see. Yeah, this was sine square theta. Okay. So you can see your sine square theta becomes this thing. So 1 minus cos 2 omega t whole divided by 2. Is it clear, kid? Now? And there's a square also plus b square. That becomes 1 plus cos 2 omega t divided by 2. What I'm left with, Kirtna? A b times of sine 2 omega t. Now what we have to do is simply integrate it. I square this, so this will take you down I square dt divided by dt. So just put all the values and do the integration. So this will become this. We have to do integration of this. We have to do integration of this. We have to do integration. So Kirtna, till now, any doubt you have till this step? Wait. Yeah, Kirtan, do you have any doubt till this step? Kirtana, do you have any doubt?
No, sir.
No doubt, right? Okay, so if I ask you, can you do the rest of the integration and under root and get the RMS value by yourself? If I ask you,
Yes,
can
sir.
you do the
Try.
rest? You can do, right? Okay, so what I can actually do right now, I can take the rest part up to you. Okay, you have to solve by yourself. Okay, here after you can solve it because I have given the way. Okay, here after just solve integration and rest to get RMS. Okay, look there. This will give you the RMS. Okay, right now this is just an average calculation, so you have to get the whole thing. I hope this is fine. We can move to the next thing. Okay, I can go further also. Like there might be the case if I give a different phases. Till now, whatever the problem we solve, they have the same phase. Okay? So, Kit, now let's talk about power of source. Okay. So the topic. So, Kit, now look. If you simply just go and calculate power and load, the formula for both is going to be the same. Okay. So, if I ask you what is the difference between both two terms, can you explain me? Kit, now look. Even though power is also power, when we talk about power of a source, okay, that is also kind of power. When we talk about load of any circuit, that is also kind of power kind of thing, right? So what is the difference between both two terms? When we can use power and when we can use load? Because ideally, whatever you are going to calculate by either power or this formula will remain same. Power is equal to this, right? So what's the difference? Where we are supposed to use power word, when we can say it's a power, when we can say it's a load. Can you explain me this point?
Like if many things are connected to the circuit, then the load should be.
Mhm. No. Look, power of a source mean to say you have a source, you know, which is providing you some kind of energy. Energy mean to say it is providing energy per unit time. So the energy which it is providing, that we are going to call it the power. Okay? Basically, the power which you are getting from the source. Okay? In that case, we are calling it as a source of power. But what is the load? Assume there is a device, right, which is consuming this energy. So we can say load of this device. Okay? Understood? Load is basically what? Overload on you something, right? That look, assume you are doing some work, so it means you're get loaded with some work, right? You are consuming some amount of energy, so that is a load on you. But from where you get that amount of energy to do that amount of work, the source will be basically power of source. Okay, at the end of the day, there's a power coming from somewhere, going in somewhere. So when it is going somewhere, okay, you are there's a load on you. You are consuming that power. Then it's a load. This is kind of thing. So let's talk about power in case of AC circuit. Earlier we have discussed this power thing when in case of your. So here if you look at this, as this is a arrangement, some arrangement of circuit is there. Assume across this the voltage is given as some function of time. Okay, so name base source is like this and it is given like this. Assume the current which is flowing through this circuit is around I. Okay, and you can call this value Vt is something V naught sine omega t. Now look, if you see carefully, I am saying, look, you were providing, you had a source, it was providing this much amount of voltage. Okay, that this was some electrical arrangement. Okay, this was some electrical arrangement because it might be say like this is a bigger case. You provided a battery. Look, this is a sign convention of alternating current. This is a sign convention. This is sign convention of DC current. Okay? That is a difference. Yeah. So you are providing this much of voltage. So, but the net current which is flowing in the circuit, this is this much. So what I can say here is your net current has a phase difference. Look, phase, what is the phase difference? It's like how much it is lagging or something, right? Here the phase is omega t. Here the phase is omega t plus phi. Now this phi can be positive. If it's positive, obviously, baat hai, if your phase is ahead of the voltage. If it is negative, your phase is this current phase is behind the voltage. Okay, it's either lagging or it's a gain or something. Is it clear?
Yes.
Okay, and I'm just giving you an idea about how the things work over here. So this is the kind of thing. This phase can be anything. There might be the case that phase is zero itself. This alpha is zero itself, right? So assume kitna I'm saying, let's calculate the power at any instant. So if I ask you power at any time t in this circuit, time t. So how you are going to calculate? You will say, sir, let's do it simply. Power is equal to this. So this also depends upon some time. This also depends upon some time, right? What's the value you can write? It will become V naught, that I naught in the picture, rest sine of omega t multiplied with sine of omega t plus phi. This is the thing you are getting, right? Now idea is again very different. They are changing with the time. So how you are going to solve it? So look, there's some relation we are going to discuss about. So before going to that relation, trigonometric identities. Look, one thing. When you are going with this chapter, you should be clear with the trigonometric identities and some basic integrations. So here the identity compares sine of A, sine of B. Why I'm going with I have sine, then some angle inside this. I have then sine, I have some angle inside. So Kirtana, do you know the formula for this one? How to separate both of them? Both of them are sine, start with cos. Okay, they are greedy enough. Now simply, what you can do, because both of the sine, start with in the first column you simply say A minus B addition. So this should be negative because they are greedy enough causes. So this will become like this. It becomes A plus 2. So the formula is something like this. So here you have to do the same thing. What you can simply say sine omega t dot sine omega t plus phi. Assume it to be the A, assume the whole thing to be the B. So here you have to do cos A minus B, this minus this. So this will become negative phi minus, you have to do here addition. Okay, you have to do addition of it. Sorry, it should be 2 also. The whole thing actually divided by 2, so this goes with other side, it becomes 2. This becomes cos of addition of it. So when you do addition of this plus 5, so this becomes 2 omega t plus 5. Is it clear, Kitna?
Yes.
Okay. Also, look, this is cos omega t, this is cos phi, right? You know cos minus theta becomes theta itself, so this comes out as, yeah. So now if you go and substitute, okay, here should be 2 also, so you can actually divide the whole thing by 2. So this becomes sine omega t sine omega t plus 5. This becomes equals to cos phi minus cos 2 omega t plus 5. I hope this is clear, right?
Yes.
Okay. So, Kirtana, look, the point is, if you see your current is changing, right? It is changing with the time. So, what the power expression comes out in the picture? Power comes out as V naught I naught. And the rest part, we have changed, we have already calculated one value for this. What is it? It is cos phi, okay, minus cos 2 omega plus 5. Whole thing divided by 2. Clear? I hope this is clear, Kirtana.
Yes.
So this is what I can say. This is your instantaneous power. Now just put the value of t, get the power. Okay. There's one more point. You need to get the phi also. Okay, that is one more point. We don't have phi right now. So the problem is how we should solve this. You know this, Kirtana. Just let's think it one way. You know one thing. The power, like voltage is equals to I by R. It means whatever the sign convention, this V is going to have a similar sign convention, I is also going to have. It means we can actually go and calculate power. Why we are talking about the power? Look, we could have calculated power IRMS. Like just we used to do in case of current, we used to calculate RMS, voltage also RMS. We were not calculating average. Why we were not calculating average? Because that changes its direction. So even though it has some value, you will get zero average in one cycle. So what we do, we calculate RMS. We do square. Okay. So for the same amount of value, it will be like this. So it will give some positive value. Okay. That yeah, this much magnitude of the current it is flowing at every time. Okay. This is so in case of power, why we are going with average? Why we are not going with RMS? Because we can get our thing by using average itself. Because power itself equals to I square RT. Understood? It itself contain a component. We are writing VI, right? It is also written in the form of I square R. This gives you I square itself. Understood? And this is what we used to do. So when you are calculating average of it, you are ideally calculating I square R itself, average of this thing. Understood? So we don't even need to do the what I can say. I don't even need to go and calculate this RMS kind of thing right here. That's why we can actually go with average itself. So yes, what we are going to do, Kirtana, here, we are going to calculate average. Is it clear now? Kirtana, let me know if you understood why we are going to calculate the average.
Yes, sir.
Okay, fine. So let's go back and calculate the average. So you know how to calculate average. Power average is equals to P dt, whatever the average calculation, just integrate with the dt and divide it by the dt division. So you know what is the time you are going to get. A complete cycle is from 0 to 2 pi. This is the basically we have inside omega t as the main part. So here only time is variable. So this 2 pi in terms of time can be written as 2 pi by omega. Okay, that is what we are going to do. How we generally write this? I'll just give you the way. Look here now. This omega t represents an angle, right? So you know when I'm saying that this should be representing zero, it means you can simply say time is zero. How to represent t in some angle? Put the angle, whatever the angle you want. So I am saying in the complete cycle, I'm talking about 0 to 2 pi. So 2 pi is the angle divided by omega. This is how we represent angle in terms of time or something. Okay, when integration is ongoing. So you are doing your integration from 0 to 2 pi by omega, and this is also going from 0 to 2 pi by omega. So here it is going from 0 to 2, so this will become directly t, put the limit 0 to 2 pi by omega. So the whole thing comes out as omega p dt divided by 2 pi. This is something we are going to do. But is it complete? No. We are yet to do p dt. So let's do p dt. This comes out as v naught I naught divided by 2 cos phi minus cos omega t, the whole thing divided by 2 plus phi is it. I hope this is the thing. Let me see once back. There are two times of it. It is two times. So yeah, Kirtana, can you see this? We have to do integration of this part, and I think we can do easily. It's very easy to for us to do, right? So omega naught I naught divided by 2. Look, this is a constant part, so it will become. You are doing it with respect to sign, so it will become. It will also come outside, so it will become actually cos phi times of t, and value goes from 0 to 2 pi by omega. 0 to 2 pi by omega. Minus, there is a negative sign. V naught, I naught. I have just separated this thing. This part is important. There is a 2 at the bottom, so I'll be writing it like 1 by 2 at the very starting. Or let's do one thing. Make it 4. If we are still in the bracket, and now we are solving this next part. If you look at this next part, how it looks like? It looks like, just remove it feels too messy for now. Cos 2 omega plus 5. If you see, this is also it has some angle, right? It depends upon them. So what is the integration of this thing? This becomes cos. It will become sine 2 omega t plus 5. Okay. Along with this, because the coefficient is 2 pi, so it will be having a bottom 2 pi, 2 omega. Okay, something like this you are going to get, and the values are going from again 0 to 2 pi by 2. So look it now. I'll just take this once. Okay. So how you are going to get this? The average of this thing sine 2 omega t plus 5. If you put this value 2, so it will become 2 into omega 2 pi by omega into what is t? 2 pi by omega. This omega was 2 pi by t, capital T. Okay. So here what if you just sorry you don't even need to include it because we are in the form of this. Keep it in the form of omega. Omega cancel 4 pi. What is the 4 pi? You are doing 4 pi plus 5. That will result in sine phi itself. And when you are starting, when you are going to put 0, that will be sine phi. So sine phi minus sine phi, that will result in 0. Okay. So the average of this portion, let me see, let me clarify this. Average of this portion is going out to be 0. What you are left with this part only. So it goes as 0 on I naught by 4 cos phi, cos phi dot t. What is the value of t? When you put 0, whole thing will become 0, so you are left with 2 pi. I hope Kirtana, this is clear. Is
Yes,
this
sir.
clear? It's clear, right? Now, anything which you can see, we can actually eliminate. Yes, we can. We should do that. Some elimination is there, right? Okay. So this is your integration of P dt coming out. Okay, makes sense. But what is my net average? This net average is basically P dt divided by 2 pi by omega. From where I got? If you could remember from the previous expression, we already had this, right? So just put the values. The moment you put the value, V naught I naught by 4 dot cos phi 2 pi by omega. This whole thing divided by 2 pi by omega result is cancelled. So what you got at the end of the day, Kirtana? And yes, I think I just did a small mistake somewhere. Mm, Okay, from where I got this 2 extra. Okay, okay, wait. I don't know why I'm carrying this 2 because already this 2 I have kept here, so it should not be carried further on. Remove it. This 2 I should have not carried because I have already made it the bottom of it. This is 2, 4. No, this is also 4. 2. It will be 2 also. So yeah, Gedna, look, finally you have got averages. V naught I naught by 2 is equals to multiplied by cos phi. Is this clear, Gedna? Gedna, is it clear?
Yes, sir.
Okay. Now, Gedna, look at this. Look at this once carefully. I calculated average, right? Can if I ask you, Gedna, what is IRMS value? You know that is nothing but what is the value? That is nothing but I naught by RS, right? What is VRM statement? Can I say that is also nothing but V naught divided by root 2? Can I say this?
Yes.
Okay, do you know how we got this? Yesterday we calculated it. So if you just multiply both of them, what you are going to get? VRMS, IRMS is equals to V naught I naught divided by root 2 into root 2. That is 2. Wait, isn't it present here? Yes. This is VRMS, IRMS. Understood the whole thing. Cos phi. Didn't you got P as basically P? This is P average, right? So P average is nothing but what it is? PRMS. Cos of phi. What because RMS value is an effective value of a varying things. Okay? So that's how you are supposed to. Is it clear, Ketna?
Yes, sir.
So Ketna, look, that's all for today's session from my side. Okay, I'm going to end the session by this. If you have any doubt, please let me know. Otherwise we can end the session. Yeah. Any doubt, Ketna?
No doubt, sir.
Look, I'll be sharing this PDF. Okay. After I end the session, whenever you get the time, please look at all the things whatever we have discussed. Might be something you won't be able to guess because the writing might not be that clear. But you can try it by yourself. Okay. Try each derivation by yourself. Otherwise, you won't be able to solve in your examination because it includes a lot of trigonometric thing. It includes a lot of what I can say. Yeah, a lot of trigonometric and integration is calculus is included. Okay. So yeah, Ketna, that's all for today's session from my end. Goodbye.